All right, welcome back to the Colloquium series on robust and beneficial artificial intelligence. Our first speaker today is Bas Steunebrink, who works at the AI lab IDSIA. It's ITSIA. And finished his PhD at the University of Utrecht in artificial intelligence. Mm-hmm. And he's here today to talk about value learning for agents in the realistic environments under computational resource constraints.
Thank you. So yeah, I'm a Dutchman. My name is Bas Steunebrink. So yeah, I've been working for, yeah, it's okay. It means just a paved village square in Dutch. So yeah, I work in Switzerland, right around here. If you would zoom in hand, you would see Jürgen Schmidhuber waving behind the window there, because I work in his lab, and for many years now already. And since about more than a year ago, we also founded a AI startup called Granulations. So Jürgen Schmidhuber is the president of this startup, and the goal of this company is to develop and market neural network-based AI solutions on large scales for cool industrial and less industrial applications. And our stated goal is also to develop really a general AI, but with the provision that we are very mindful of potential dangers and pitfalls of building such a system. So, and I am, as some of you know, already very mindful of these things. Actually, I'm still fully employed at ITSIA, working on a grant from the Future of Life Institute, which is this grant thing set up through a cash injection from Elon Musk to develop or try to think more about robustly safe AI. So I'm working on that. And I already talked with a few people. I see also some new people that were not here this weekend. When I arrived, we talked already a bit about what I was going to talk about. And quickly, my talk was renamed to Bas's super pessimistic value learning method. So, yeah, so where I come from, I would say it is super pessimistic. I'm just usually very careful to make simplifying assumptions. So you could say that's pessimistic, or you could say that's realistic. So my favorite analogy, which we also discussed a bit on Sunday already with a few people, I always like to make the airplane analogy, where you have your clever engineer, but it's the year 1900, and he wants to build the first airplane. And he thinks, well, it's pretty difficult. Let me first write some calculations on paper. And then he figures out on his calculations, it's still very difficult. Let's make some simplifying assumptions, because the airplane, according to my calculations, keeps slowing down and eventually crashes. So let's scrap friction from my equations. And then he runs the equations again. He sees, the airplane still crashed. They're being pulled down by some force. So let's also scrap gravity from my equations. And then suddenly his equations work out. But what he has effectively designed is a spaceship. And this is really a very different solution. This is not something that will work in the constrained real-world environment that the airplane was supposed to function in. So I'm always wary to make simplifying assumptions. I'm much more, I always like to really attack problems head on in that sense. So with respect to, when it comes to teaching some values to our AIs, the simplifying assumptions that I did not want to make is that we are wise enough as humans to come up right from the bat with the perfect utility function for this agent. So I want my AIs to be able to figure out over time and accept updates and polishings to the the utility functions or value functions or whatever you want to call them. Second, I am very hesitant to try to axiomatize the agent or its environment, because we are talking about extremely complex agents and environments here that we want our AIs to work in. So what if we cannot even do that? And what if also we cannot really hope for optimality, because the agent will not have enough resources at its disposal anyway? So I really want to discuss with you here now what are the ingredients that are needed to develop a system which can still learn safe and robust values despite all these pessimistic assumptions, if you will. And whenever I talk about values, I do mean really human values, as in do not kill, do not become a populist politician, these kind of real values. Do not waste resources unnecessarily. This is also really important value in my view. So a few disclaimers before we dive in is that I still would really like to see more formal approaches to the value learning problem. And I see this line as a line of reasoning in parallel to that. So by all means, if you're working on the formal methods, do continue that. In this talk, I do not really intend to show any results. I'm more asking you to think with me about the necessary ingredients to make this pessimistic setup work. And therefore, this talk will be necessarily quite informal, and I will be happy to be interrupted at any time. Make this into some kind of moderated discussion, if you will. And I have enough slides to fill the hour, but I really don't care if I finish them or not. So if you think like, oh, this is ridiculous, or why would this work, just say so. Let's have a good discussion. So the key ingredients of a setup where this pessimistic value learning would work, in my view, needs two kinds of details. One is architectural details, the other is methodological details. So we need to specify some ingredients of the agent that we're building. For example, its knowledge representation, goals, and how do you specify goals and constraints to it? How does it learn? How does it select actions, solve the control problem? And besides that, there's a really big methodological issue, that is, how do we teach and test the system, and how do we measure its growth and its stabilization, the way it settles on its values. I think the methodological issues are often also a bit underappreciated, but I think these are extremely important as well, and I will come back to that. So this is the big picture. This is about the level of detail that I would need to describe the architecture of an agent that would work in this pessimistic setting. So all I will say something about the way knowledge is represented in what I call granules. We need some humans specifying and updating requirements which the agent can use and take an update at any time, and there will be some processes that act on its set of granules, its knowledge basically. So let's go into that. First of all, what do I mean with requirements? Requirements, just technically taking sort of an engineering, taken from engineering parlance, is these are goals and constraints. I do not even say we need rewards in a sense. I would just say we need goals and constraints, goals being a future state that you can specify. For example, I want all the dishes, the dirty dishes in the sink to be clean. This is a goal that you can specify to an agent, and the agent has to somehow figure out how to go towards that goal. And there's constraints which are sort of the negative of a goal. For example, do not break any dishes and be done within 15 minutes. These are constraints that you would also pass as part of a task to an agent. Another important capability of our pessimistic value learner is a capability to perform simulation before commitment. With that I mean is that it should be capable of running what-if scenarios. If you specify a goal, it will want to find some course of action to achieve this goal, but before committing to this course of actions, it must simulate what will be the effects of my actions, and will they violate some other constraints that I have in my system right now, such that it can decide whether and which of its possible plans are proper courses of action. Another extremely important point, in my view, is that knowledge should be decoupled from goals. With that I mean that the knowledge representation itself should not in itself contain anything about goals. It should just contain stuff about phenomena in the environment. This allows the controller, which is the part of the agent which couples knowledge and goals to obtain actions. This can then make this coupling dynamically. And this is extremely important because the human might update goals and constraints at any moment, so the agent must be at any moment ready to re-evaluate the course of actions that it has committed to against whatever updated constraints using its very latest knowledge. Any questions so far on this? Maybe it's hard to see how this should be implemented, but I will show you a bit later that this stuff actually works. Knowledge representation. The only level of detail that I would like to go into is that it should be represented as what I call as granules. A granule is a very small piece of code that has the functionality of both a forward and an inverse model in the sense of control theory. Maybe I should make a drawing of this, what I mean with that. Huh? My clicker's falling apart. So, unless everyone is completely familiar with control theory, what are forward and inverse models. So, see here I have a little piece here. Forward model. If you have an input X, this one will say, a forward model will say, I predict that Y will happen next sometime in the near future. And a backward model will do the other way. If you have a goal Y, it will say X should be a sub-goal. And if you wrap two of these together, that are related, I call this one granule. I chose the word granule because it's a very small thing, but still has some internal structure. So yeah, and as I specified, the controller can use these kind of granules to chain them dynamically. If it has some end goal, it will repeatedly, on the fly, find these backwards model that will lead it back to basic actions. And at the same time, whatever comes in through the sensors, it will be able to make predictions for that, and also the simulation can be seen to be implemented in this way if you do the backward chaining from a goal state to a possible course of actions, then before you actually start executing the actions, you can run the same granules forward to see what would happen if I would do these actions. Comes up with some predictions, can check predictions against other constraints. If they conflict, this means these are bad course of action. These granules, they are subject to 3 processes: additive, subtractive, and compressive processes. So, of course, the system needs to be able to learn, so it adds them on the fly. If it needs to find some explanation of something that it could not explain before, it can add a new granule to the system to capture this phenomena. It should do that tentatively, so with very low confidence, such that over time it can observe the accuracy and efficacy of this new granule and slowly phase it in to participate in the actual chaining that will lead to actions. And if the model turns out to be nonsense, it can delete them before it has affected its actions. So in this way, it does not actually need to reason about any self-modifications. Self-modification being the addition and deletion of models, they all can be completely vindicated and falsified based on experience.
When you say no reasoning about self-modification,
yeah,
I think that you don't mean that there's no heuristics for what to actually add or subtract. Right?
Yeah.
So there might be reasoning of some kind.
There are heuristics used in the implementation in the system, but once it has been started, there's no need. You just need to make sure that all the triggers for adding new granules are sufficient and complete to do proper learning.
I think rephrase. I would be more agreeable if you said no reasoning about direct self-modifications. There are, of course, actions which can result in self-modification, and it's perfectly possible for this architecture to reason about that.
Yes, of course, but this is this is a very good point. But what you said, this is more about choosing to put your attention to phenomena in the world that you do not yet understand, hoping that you will learn more about them, which will, by construction of the system, lead to new granules being built in the system. And this way it can sort of steer.
I think Avram and I are both worried about wireheading as a particular case of something that doesn't fit what you were looking for, but may in fact happen with such an architecture.
Can you rephrase? Is that the question?
Yes. It's a question. For instance, self-modification to wirehead is, I think, something that is possible in this architecture, but not desirable.
So far, it is possible in a way, but this is where values come in. They should prevent this, and I will get back to that. So, of course, as we go along, I will claim a lot of things about the necessity of these particular ingredients, but it may not be clear how they all interact to become a safe system until you've seen all ingredients together. Because each of these ingredients in isolation sounds cool, but you can always come up with some caveats that say, okay, this may not work, but with the whole picture, I plan to, when I complete the picture, it should be clear that all things combined should result in a more robustly safe system. Stuart?
So just to clarify, and based on research just before, if this agent gets a reward signal from a human pressing a button, it would not rewrite itself so that the signal is interpreted to always have maximal value, but currently would shoot the human and press the button itself.
In lieu of more details on the value learning.
Yeah.
So for the current setup.
In the current setup, if the human pressed a button and it did not expect the human to press the button, then it means that it had not sufficiently many granules to predict this, so it needs more. It needs to build an explanation of that to do the credit assignment.
No, that's not what I'm.
All right.
So what if it adds a granule that just says, like, alters the signal to always be on? Is kind of
Yeah. That does not exist in this setup. The granules are just explaining how you say, sequences of inputs as being put into the system. That's what they're capturing. They're not modifying anything. They're just capturing.
Yeah, but I mean, you can have a granule which says, I predict that if you shoot the human and press the button down yourself, you will receive this signal from the environment.
Yes.
And if you want to receive the signal from the environment, then you can shoot the human and press the button yourself.
Yes.
So it is like indirect self-modification like this is possible and needs to be blocked out with the value learning part to come later.
Yes. And we already saw a hint of that because the system, as I said, must do simulation before commitment to actions. So if it simulates this course of action of killing the human, this will flag a violation with the constraint that it should have that killing humans is not allowed.
This is assuming you entered all constraints that that you could think of a priori about.
No, not a priori. That was the whole point. You do not have to specify this a priori. You want to specify as many as you can a priori, but I do not assume that the human designers are perfectly wise and they will need to polish and probably extend this set of constraints over time. And this still may sound dangerous, but I claim that there is a significant period of time during which system is not yet as powerful to really harm humans or deceive them, and where you have time to polish this.
So the system is not adding constraints.
It's not one?
The system is not adding constraints.
No.
You're not trying to learn these constraints.
No. The constraints are added by the human. Goals are automatically, autonomously generated by the system using the backward chaining, but constraints are imposed by the human.
So goals and constraints, the way you find it, it sounds somewhat binary. Like a goal is either reached or not reached. The constraints either violated or not violated. But in reality, everything is probabilistic, so you cannot really know for sure. I mean, you cannot reason like this plan would violate the constraint. You can maybe reason that this plan would violate the constraint with a certain probability.
Yeah, of course. Yeah, I did not go into that, but this is a completely valid point, and this is something that we have. So there exists at least one system which implements this, and it does this comparison of probabilities, of likelihoods of certain course of actions leading to violations. If those probabilities are extremely low and the goal is very valuable, it might still commit to doing it, and vice versa. So, and there was another point. What was the first point you made? Was the binariness of it. I did not say explicitly, but goals and constraints can be underspecified in this case. So they do not need to capture exactly the exact numerical values that you need to see.
How do you imagine the specification to work, and what language would the human operator use to specify this goals and constraints?
Whatever works, and I will show you a little scenario later, for which we had sort of a kind of programming language to specify these goals and constraints to it. But I mean, there's no reason why it needs to be so difficult to be graphical interface.
Because you're trying to make an AGI, you have a bunch of pieces of knowledge, pieces of goals. You're trying to make an AGI out of it. So you need to know what they're all doing.
Yeah.
Why do you think that's going to be not a big challenge?
This is going to be a big challenge. This was one of the main points, is that we also need to dive into the methodological details of teaching, testing, and measuring growth of the system.
What I mean is, when we specify the goals in certain language, then this language uses certain concepts. And so the agent has to know how to map this content.
Exactly. And this is related to the issue of understanding. So the system might, in the beginning, not understand even what these constraints mean,
or
because
it
has not.
Or it might understand them incorrectly.
Yes, exactly. And this is something that I will get to later. Understanding is a very important part of the large bridge. I'm very happy you say that, because this is exactly in line with what I'm going to present. So, just to conclude here, this set of granules is self-expanding and self-pruning as well, based on experience. Initially, you will have to specify a small seed of initial granules just to bootstrap the learning. Nothing comes from nothing. But this should be as small as possible.
Sorry.
Yeah.
This is sort of vague, but like, what's the type signature of a granule? Like sense data to.
Yeah. So you mean what could an X or a Y be?
Yeah.
They are just vectors of numbers, in a way.
Like do like more specific like visualizations.
Yes, maybe that's the next slide actually. So just to show that this is not hot air, at least one implementation exists of this kind of system. I call this class of systems XPI for Experience-Based AI, because they gain all their knowledge from experience, from interaction with the world, and they do not prove anything about their own growth. And I showed also already this video on Sunday to some people here. So this is we implemented this system here and tested it in a scenario where we have first, these are two humans. They may not look like humans, but this is just the rendering of the scenario as observed by the agent. So there's two humans that are having a conversation about the recycling properties of some objects on a table between them. And in reality, there were actually two humans with tracking gloves, eye gaze tracking, and microphone for speech recognition. And the system was observing in real time the movements of the people, their pointing gestures, and their direction in which they were looking, and all the words that they were saying. So we did not solve the speech recognition problem in this scenario, just the words were, the signal was run through an off-the-shelf speech recognizer, so just get the words. Although there was a lot of noise in it because one of the two guys, our lead engineer, he has a very nice French accent, so the speech recognizer was having a lot of trouble with that. But all the better, just to show robustness a bit. And the system was observing interviews. So one guy is asking questions about these items on the table to the other guy, and the other guy answers them, just using unscripted, full natural language sentences. And the system was observing this in real time. It got the words as they were spoken, with the timestamps at which they were spoken in real time were streamed into the system together with all the gestures. And after about 20 hours of observing different 5-minute interviews, we were able to put the system in to give it a new goal. So originally the goal of the system was just to observe what is happening. The only cue for it was that the interviewer at the end of the interview says thank you. That's the only goal that the system had in this observation task. Figure out why one guy says thank you to the other guy. This was everything that was specified in the seed. And after about 20 hours of observing 5-minute interviews, we were able to put the system into the role of interviewee and answer questions about the objects. And it did so at several levels of competency, I don't know how to pronounce the word. So first of all, it was able to properly sequentialize words, output the words, because the system was massively parallel. It could in principle speak with 3 voices if it wanted to, but it learned no words come one after the other, they don't come in parallel. It had picked up structure of grammar, at least the grammar used in these scenarios, which was actually not scripted. We did not provide any English grammar to the system. We did not provide any scripts to the guys doing these interviews, but still the system was able to pick up which words would follow which words if you would follow proper English grammar. On top of that, it learned that there's such a thing as question answering, turn taking. So one guy speaks, gives a nod or a longer pause. That means it's the turn from the next guy. This it also picked up. It also picked up how to figure out what is the topic of conversation. So the system was actually capable of answering exactly about the object that you were asking. If you would say, how long does it take to recycle a glass bottle? It would actually answer something about the glass bottle based on what it had observed in terms of answers in its scenarios that it has observed. And not only that, the system was very flexible. You could give another goal to the system, say, now don't be the interviewee, be the interviewer. Sure enough, I mean, it had observed the interview, so why not? It started constructing questions about these objects. And you could even set additional constraints if you would then say, also finish this interview in 5 minutes, and the human interviewee would start answering really slowly. The system was able to plan minutes ahead, figure out at this speed I'm not going to be able to run through enough questions. I will violate my time constraint here, so I need to start interrupting this guy to speed things up a bit. It did not have the constraint that it was not allowed to interrupt the guy. So it just had, if it had only had the constraint to finish the interview in time, it would start interrupting. So, any questions about this? I mean, this is just to illustrate that a system as specified with the granules, it works in really non-trivial scenarios.
Can you show the example video?
Yeah, I can. Want to see it? So, I don't know where sound will come from.
Then a plastic
Yeah.
bottle, which releases more greenhouse gases when produced, an aluminum can or a glass bottle. Making an aluminum can produces less greenhouse gases than a new glass bottle.
This humans.
This
Yeah, this is the 2 humans. So
cardboard box is made from natural wood fibers. Wood comes from the forest or from recycled.
So, just pausing it. So, these were the 2 humans doing the interview. The system was just observing, trying to figure out what made the interviewer say thank you to the interviewee after about 5 minutes. And as you could hear, they were using just normal full sentences in English. They were pointing at objects. They were not always even saying what they were talking about. Sometimes the guy was saying, like, can you tell me more about this? While pointing at some object.
Do you have the example when the machine does the interview?
Yeah. So interviewing a human, being interviewed. So this shows the system being interviewed by the human. So you will hear that one of the guys has a more robotic voice, so that's the speech synthesizer.
What is this
That's the human, that's the machine.
This cardboard box is made from natural wood fibers. Wood comes from the forest or from recycled fiber. Fiber cannot be recycled endlessly like metal. Cardboard boxes are biodegradable. Cardboard box takes 2 months to disintegrate in the sun. What is this? This newspaper is made from natural wood fibers. Recycled paper can be used to make new paper.
So, you can see it's grammatically correct what it's saying, even though no grammar was given.
Although it did say it takes this cardboard box 2 to 4 months to disagree in the sun.
Well, might be. That may be either a problem with the speech synthesizer, or maybe it was because the text-to-speech that it had observed. Maybe the how you say the off-the-shelf speech recognizer that we used did not properly figure out the difference between disintegrate and disagree, and so that was a noisy thing. Yes, Alex?
What inspired you guys to make the humans look like weird aliens?
Icelandic vodka. Yeah, that was a mistake. So, yeah, there's also an example which is actually pretty boring, where it shows that there's an interruption, but yeah, it's just first 1 minute of the human answering questions really slowly, and it's pretty boring, and then you see that the system starts interrupting it. So, let's get back to the presentation. So I would even go so far as to say that a system with this setup would be capable of recursive self-improvement, which is maybe the most controversial claim I'm going to make today, so feel free to criticize us to that.
Yeah, okay. So you made a point earlier saying that no reasoning is involved about its self-improvement.
Yes.
And now you're saying it does recursive self-improvement. So how does that work?
How does that
as I understood, the granules are being added by fixed mechanisms.
Yes.
Which means that no matter how smart the system gets, its learning algorithm is the same, right?
Yes.
So how is recursive?
Only its lowest level learning algorithm is the same, because it does also have a focus of attention. So there's a positive feedback loop between the goals that it has and its attention to what it wants to do. So the higher quality the granules, the better it will be able to achieve the goals and focus on actually achieving its goals. The more it will learn about what matters in the world, the more it will pick up, and the more high quality granules it will gather. This is, of course, there's one caveat there, is that the environment may have lots of hidden causations which it would not figure out if it would not have some kind of intrinsic motivation to find the caveats in it, or find generalizations or analogies or whatever in its own granules. So I do insist there must be something extra besides these learning mechanisms that I told you about. Also, one assumption is that the world is not too deceptive and adversarial, so otherwise it would just be garbage in, garbage out.
Do you think it's possible for it to learn to manipulate its learning processes?
To manipulate what?
To somehow gain these heuristics with the learning processes?
I think this is on a very different level. I mean, this kind of behavior you're talking about gaming things, this is based on thousands, millions of granules interacting to give rise to complex behaviors, whereas the way the granules are learned is so far down. I don't I don't see such an immediate connection between these two.
Could the system learn to program, for example?
It could. This is something we'll get into later because, as I specified earlier, the mechanism, the controller, which couples knowledge to goals to come up with actions, the controller is not the seat of intelligence, and it's also a fixed routine. And so it cannot directly manipulate its controller to handle its motivations differently. But of course, obvious caveat is that if the system learns to program, learns to perform self-surgery in some other convoluted way, this might still break this setup. But that's exactly where values come in, as I will get to later. Of course, some values specify that it should not want that.
Well, so I mean, it doesn't have to be self-modification. Like if I program another AI system, if I'm an AI system and I program another AI system, that's like as good as self-modification. Like I could.
Yes, but okay, let's go to the issue of values then, because this will answer your question to see how this is stabilized, this setup. So the point is, to get to values, we first need one other very big very important ingredient, which is understanding. And so the point is that having a seed, having the capability, if you will believe me, my claims that this system can grow to become a very powerful system to a seed. Just having this seed and the system does not mean we have a mature AGI. So we still need to find some methodology of growing this system, of teaching it, testing it. So the most important thing, first and foremost, to test is its level of understanding of observed phenomena. I will specify what this means in a second. Only this way to answer your question, I think, is only if it has proper understanding of phenomena in the environment, can it finally connect its actions in the environment to previously unspecified but now understood constraints that were imposed by the humans. I accidentally pressed the wrong button. Okay, so my favorite way of illustrating the issue of understanding, what is understanding, is to show a picture like this. The question is, if you would train your favorite AI algorithm to recognize tables and images, and you would show this image to the system, would you expect this system to answer yes or no to the question, is this a table?
I expect it to respond with a table flipping emoji.
Yeah. I actually considered putting that emoji in there, but in the end I thought this was such a nice picture of a table upside down. So yeah, I've already said this to a few other people during the week, is that it's a trick question, of course, because a system that really understands tables would not say yes or no to this question. It would say, well, it's potentially a table if only you would flip it such that it can actually fulfill its common role as a table, namely to keep objects a certain distance from the ground. So the system that can answer a question like that, this shows understanding. And that means that understanding has to do not just with some visual properties of phenomena, but really with the usage of them as well. So, I have with a few colleagues of mine a paper about this issue of understanding at the AGI conference this year in July next month in New York City. And we did some research on it, and it seems that the whole issue of understanding is sorely lacking from AI literature. The only only time when the word understanding is actually used is in natural language understanding, but there the understanding is not really the kind of understanding that I'm talking about here. So, what is understanding? Here's my definition. Our definition is that level of understanding of a phenomenon phi is determined by the completeness and accuracy of the granules relating elements of phi, both within phi and to other phenomena. So, yeah, that's probably a lot to parse.
So,
but
taking it maybe like outside of the realm of granules, it would be having some sort of complete theory of phi.
yes.
In whatever knowledge representation.
It doesn't have to be complete. I was saying the level of understanding. So understanding is not binary. The better you understand a table, the more complete and accurate this set of models, granules, theory, whatever you want to call it, is with respect to phi, in the sense that it relates parts of phi to other parts of phi and to other non-phi parts in the environment.
So I'm slightly confused by this concept of granule, because it looks like by this diagram that there are two things going on here. One is predictions, which means some ability to model the external environment.
Yeah.
And the second is the ability to break goals into sub-goals.
Yes.
And what I don't understand is why the two are necessarily coupled, and like what does it mean for a granule to, I mean, what is the relation between these two errors? Like how is, how is the overall capability of the system to model the environment why is it necessarily possible to break it down into modules in this way?
It is possible at the lowest level. You have your sensors that give you input, that will probably give you vectors of values, and so what goes in on one side of a forward model is a vector of values, and out comes a transformed vector of values, which is a prediction. Now this is very hard at the lowest level.
Prediction for the same type of values. If
Could
what
be.
enters here
Yes.
are pixels from a camera, then the output is what the system expects the pixels to be in some time in the future?
Yes. This is at the lowest level. This is one way to see it. Another way is that these X's and Y's can also be more abstract events. So in our system that I showed, the interview system, what it does as well is every time a granule fires, it doesn't only produce a prediction, it also produces another internal input that says, I just fired. And this can be also picked up by granules and can be used as left or right hand side, such that granules can be hierarchically composed.
So when you say that a granule fires, you mean that the granule is also some kind of classifier?
It is a sort of a template. It's a program. No, it's more like a program that only runs if an input matches either the left hand side here or the right hand side there. So if an input comes in either through sensors or through some internal event, every time such an input is produced, it is run by the set of applicable granules. Each one that matches this input fires, and they all fire in parallel.
Okay, but I mean, this seems like these templates are one functionality, prediction are another functionality, and breaking down the sub-goals is like a third functionality. Not sure I understand how all three are coupled together and bundled in this granules.
Well, that is the point about a granule being a very small thing, but still having some structure, and it has, as you say, at least two functionalities, namely to produce predictions in forward mode and to produce sub-goals in backwards mode.
And this template recognition is like a third one. Oh, how do
No, yeah.
That's part of the first one, right?
No, the template, I mean, that is that's what, just to say that this is, a granule is not constantly running. It is a data-driven piece of code. So it only runs or fires, as I said, if something matches one of the input points.
Okay, then when
In that
it
sense,
runs,
it's a template.
if it runs, then it produces this prediction.
Yeah. And the prediction is added to the pool of inputs in the system, and this prediction can then be picked up by another granule on the left-hand side, which produces another prediction.
So can there also be contradictory predictions in the system?
Yes. But each prediction also has a likelihood attached to it, depending on the confidence and accuracy of these granules. So there's some control parameters.
Okay.
So it can have different conflicting predictions, but when it comes time to act on these predictions, it can choose the ones that it's most certain about.
Okay, so coming to the original question, what is the interaction between this left arrow and the right arrow? How this arrow
Between this
couple
and
to
this?
each other,
Yeah, it's basically one guy. I drew two boxes, but actually there's just one box, and it has a left-hand side and a right-hand side, and both can take input. And if the left-hand side takes an input, then the output will be a prediction. If the right-hand side takes an input in the form of a goal, then the output is a sub-goal. Or if it takes an input in the form of a normal input, then it can also output as an assumption.
Do you have maybe some simple examples, just for illustration? Some very simplified example of some system of granules or something?
Yes, well, if you think back of the interview scenario, the words being spoken.
Many granules.
Yeah, it's composed of thousands of granules.
Okay.
In the end, a lot of them garbage as well, because it's still actively learning. If you would observe I don't have a grasp of that, but if you observe the size of the set of granules in the beginning is really large, because it's just producing a lot of them at very low confidence, because it's just like, what the hell is going on here? And this settles over time. Some become more confident because they are firing with high accuracy.
Sorry, I interrupted you. Well, you were about to say like the type of a granule. One example would be like a thing which X had the form of a word and Y had the form of what?
Also another word, for example. So the X could be the, and Y could be bottle. In this case, where words were the most basic kind of inputs.
With some time attached?
Yes, exactly. So yeah, this system does not have any time steps as is common in AI algorithms. Everything is stamped with real-time stamps. So in this case, in the case of granules, it's a relative time. So the output, the right-hand side, gets a relative time added to it.
Okay, so the granule, for example, can be responsible for some specific word.
Mm-hmm.
Yes, it can, for example, say that this word is always followed by this word. Let's say, for example. And then, like, what would be the other direction? Would be if I want to say this word, then what I have to say first, or something like this.
So yes, if you put the system in the role of interviewee, then you would say you just give one goal to the system, that is, make sure you observe the words "thank you," and it all propagates backwards from that. So then the system starts planning and sees that, okay, to get "thank you," I need to answer this guy's questions, and so if he prompts me with a question, I need to answer, because that's the way I have observed through hours of observation, that's the way to get "thank you."
So there would be some top level node which would be able to predict when "thank you" is said on the one hand, on the other hand, receive the goal of saying "thank you" and break it down.
Yeah.
So like a granule is like a piece of causality or something?
Yes, exactly.
Did the AI get input where the interviewer didn't say thank you at the end? The interview somehow failed.
No, I don't know. These were not in there. I mean, this
constraints can be motivated by the thank you.
Well, this was the only signal we gave to the system, and it was really focused on that anyway, because that was the only signal. So,
Are some interviews longer than others? Or
sorry?
Are some interviews longer than others?
Yes, we tried to make them sort of 5 minutes each, but they were not scripted, so some were a bit longer, some were a bit less long.
Okay.
Yeah, I have no examples to show you of where we are probing the system to see where it breaks. We were already, I just have the videos of where it goes right. I mean, but this was very robust. You could just have this conversation with the system. I mean, yeah, because it did not observe many counterexamples. So many of the scenarios, they were noisy because the speech recognizer was making errors and stuff. But we did not really try to put it off, to suddenly start talking about the weather outside or something. This I don't have any demos of. But that would basically be a case of garbage in, garbage out. Because we did not teach it anything about the weather, so why would you expect it to answer in a proper way to that? So, that scary definition of understanding basically breaks down to at least 4 capabilities that the system must have in order to be said to understand a phenomena phi. It needs to be able to predict elements of phi from happening or how they happen if it observes some cues to that. It should be able to achieve goals with respect to phi. So, given the goal of putting an object a certain distance from the ground, it should be able to use the table to put this object on the table. It should be able to explain phi in the sense that explain how the components of phi interact. So a really high level of understanding would allow the system to explain why a table needs legs, because otherwise the surface would fall down itself as well. And the highest level of understanding would be demonstrated if it could actually create or recreate phi. So if you could say, make me a table, and it could figure out how to actually build you a table, that would be really good understanding. So we see here, a system doesn't need to be able to do all these things, but levels of understanding is really on a gradient, you can say, which you could each test for as well. So, I don't know how we are going on
So
the time,
if
or
you want, yeah. So it's
I mean, we now get
it's noon now. If you can get quickly through the points you wanted to say, and then we can have time for questions and after a few questions.
Yeah, we can take it offline for those who find it interesting. Yeah, because now we get to how this all ties into values, and you'll probably have a lot of criticism on that as well. So, but probably we should take that offline for those who want to criticize me. So let me just very quickly go through this. So values in the first place are of the form of constraints. They mostly tell you what you are not allowed to do. These constraints may be underspecified, such that you may, especially in the beginning, not really know what phenomena are related to these constraints. Therefore, agent must build an understanding relating these constraints to phenomena in the environment. However, building this bridge from phenomena to constraints is not enough, because take for example a psychopath who may very well realize how bad it is to kill humans, how bad it is for society. He may not actually feel compelled to adhere to this constraint. So we need additional ingredient to be able to talk about values instead of just constraints, is that values require an agent to be compelled to adhere to them. Now, I could argue that given that the controller was specified not to be modifiable in any direct way, we should be safe. Of course, you would say probably not, because the system, if it learns to become really clever over time, it might start doing some kind of self-surgery or programming new systems, which would still violate its constraints or violate its values. So this is also not safe enough yet. It is safe enough for the early teaching period where the system is still trying to figure out what are the phenomena in my environment in the first place. But it's not safe in the long run. So we need two more ingredients here to really get to values. We need to somehow instill some value that it should value the persistence of values, and ensure that the understanding of each value that we want to impose on the system stabilizes. So that meaning that the understanding or the relationships that it has built that relate phenomena in the environment to this value, that they do not at some point do not change so much anymore. This, let me skip a little bit here. So this can be seen as, so the thing is with, since the system is so data driven and different course of actions, different I say chaining paths may lead to conflicting course of actions, but if many courses of actions would be logically inconsistent but equally likely or effective according to the system, this would mean by necessity that these are not very effective paths of actions. So the pools of knowledge that turn out to be effective will necessarily be also more logically consistent, where really the one path of action will be trumping the other one in terms of utility and likelihood. So we need to make sure that our XPy systems tend towards progressive logical consistency. So we need to teach them to reliably explain and predict and interact with the phenomena that we care about. And in this way, if we have that setup with the two meta values that I just explained, the system should be pretty robust against influence, being either from other agents, environmental forces, or even from itself, because given the simulation capability of the system, as I specified it, it will be able to simulate its courses of actions more and more accurately as its knowledge becomes more and more logically consistent, and figure out that even doing self-surgery or programming other agents to do things that go against its values is actually against its values, so it should scrap these plans. I think we can quickly stop here. By these closing remarks is that this whole approach, we started with a very pessimistic set of assumptions. What we have in the end is something that places a lot of importance and responsibility on the teachers during the sensitive early periods of these AGIs. So logically, we should have some kind of regulations, maybe even laws, on who is allowed to teach these baby AGIs, because since they are sensitive and could go in any direction, especially in the early stages, garbage in, garbage out, so bad teachers will give you bad systems. There's no, given these pessimistic set of assumptions, I see no way to avoid bad outcomes if you train it badly. So, lots of responsibility on the teachers.
What would such a law look like?
What?
What would such a law look like?
Well, I mean, we have laws already for schooling systems for kids, and we have checks on schools. We have regulatory bodies
But this seems to be
visiting
much-
schools to check on the results, to check on the way children are taught. Because we have recognized that if you teach children badly, they will become bad adults later. So,
This seems to be a much different case. Like,
yeah.
humans are kind of okay, even without a teacher, right? Like,
I don't know, I don't think so. This is actually what the whole field of pedagogy is about. It is about figuring out, with respect to kids, their progression, their growth in especially their moral reasoning, their values, and deciding when it is time to intervene or whether everything is going well.
but as far as I understand, a human does not tend to become a sociopath just as a matter of like interacting with other humans on a regular basis without like
Well,
certified teachers.
Like not literally everybody who didn't go to school
Yes.
in history of the earth is a sociopath.
Yes,
In fact,
but
most aren't.
those people who didn't go to school will also probably not be so capable of being a very big influence in the world anyway. So
Sure.
But yeah, his point is just that the stakes are higher, and it's hard to imagine.
A public certification system for AI teachers that's actually good.
yeah,
Difficult
of course.
to imagine.
And the human mind has some, natural checks and balances in place that
Right.
machines
Yeah.
Right, right.
So we may yet also figure out a good set of constraints that we can put already in the seed of such systems, such that we get this kind of stability even with the lack of teachers already. So far, I don't know of such a body of constraints, so that's why I'm proposing this kind of interactive way of training systems to figure that out.
I guess what I'm thinking is that
We
okay,
yeah, so that's for the
sure.
Sure.
um,
Yeah, this is. Yeah, I can stop here. Yeah, just ruminate on this comic, and that's it.